Hello everyone, we are going to start. This is the second talk of the React Math user group. This is a talk about testing React applications by Philip at PhilipTC on Twitter. We're kindly hosted here by Telefonica. And if you guys want to join and give a talk, we need speakers. Like always, and after that we're gonna go to have beers to how's the place name?
I don't know the name, but it's right around the building. So we'll get together there, so there's no way of losing it.
So that's it. Let's start.
Thank you. All right, so again, welcome everyone. So this is the second talk, and it's gonna be about testing. My goal was to orient it towards React as much as possible, but I found that some intro is needed on the different frameworks and tools. So a part will be, well, first a little bit about me. So that's me on Saturday. Had a great time. I used to be a PHP developer, and before that, I used to be a Drupal developer. So don't hold that against me, please. I've also been developing some AngularJS a year ago, a couple years ago maybe. And now I'm working at Sourced. I'm doing mainly React, but now I've been doing Go for some months. So I'm a little bit rusty on JS right now. A little bit about Sourced. So Sourced is a platform, is a system where we're using GitHub and other Git sources to find developers and find good technical talent. So what we do is we basically index GitHub, and with GitHub indexed, we search developer profiles, categorized by their skills and in different languages and ecosystems, and we use that to improve recruitment, right? Because recruitment in our sector is horrible, as you may know, and you may probably get about 3 LinkedIn recruiters a week asking for stuff that you don't even care. So we try to fix this. So anyway, this is a little bit about me, about Sourced. This is what we're doing. Now a little bit about this talk. So as I was saying, it's going to be divided into 2 parts. First, I'm going to talk about some basic vocabulary, assertion libraries, testing frameworks, testing environments, what that means, what tools there are in each category. And then a little bit about specifically testing frameworks. We're going to talk about some unit testing frameworks like Jasmine, Matcha, Jest, Ava, sorry. And then a little bit about end-to-end testing. So I'm going to talk specifically about Casper.js and Nightwatch.js. So this is going to be a little bit more general. And then I'm going to talk a little bit more about React. First, unit testing. I'm going to talk about Flux and State and Redux, and about component testing. And also then, of course, end-to-end testing. I'm just going to do a quick example with Nightwatch.js. So before we start with vocabulary, I want to do a quick show of hands. So first off, really easy question. Who of you guys is a professional front-end developer right now? OK, keep your hand up. OK, that's about 3/4. Keep your hand up. Keep your hand up if you have ever done front-end tests. If you've ever done front-end tests, keep your hand up, okay? A couple of hands went down. Who's doing tests right now? That's end-to-end or unit. Okay, pretty much the same hands. And who is doing right now both end-to-end and unit tests? Oh, all the hands went down. That was my expectation, so okay. All right, so let's start. Vocabulary. First off, pretty low level. The lowest level are assertion libraries. So they are split into, we could say, 3 groups. They are the ones that do 2 big groups, the ones that do more behavior-driven development sort of style, and the ones that do a more test-driven development sort of style. I would say behavior would be more like should or expect. In this case, examples would be should.js and expect.js. You can see, I guess you can see the code, right? Everyone can see that? Yeah. So, and then assert would be the test-driven development style. Very basic, you've probably seen this. This also looks a lot like what we do in Go. Basic assert. And there's also must.js I've also found. And then, of course, the style you choose is totally to your liking. You can, there's no one that's better than another. It's all semantical. I like Chai because Chai allows you to actually choose the style you want. So it comes with 3 styles: the should, the expect, and the assert. And I also included Synon.js because I think it's interesting to have there, because it's not an assertion library, but it gives you very interesting stuff like being able to set up spies, stubs, and mocks. All right, pretty much that to assertion libraries. Going on, testing frameworks. So testing frameworks basically give you, in this case, 2 things. They give you a runner with an interface to execute, typically a command line interface. It also gives you a library for setting up test cases. The typical ones are QUnit, which is a little bit older and has a lot of has been used a lot for jQuery developers. Then Jasmine and Jest go together because one builds up on the other. I'm going to talk about that later. And then Mocha is pretty popular, and Ava is a newcomer. I'm going to talk about all those except QUnit. QUnit I'm not going to mention. Then end-to-end tests. There are a couple. There's Casper.js, which is pretty simple on top of Phantom.js. And then there are some Selenium WebDriver built ones, which the most famous lately is Protractor, which is, you probably know this, made for AngularJS. And it's pretty tightly coupled, unfortunately, to AngularJS. Then we have Nightwatch.js, which is more of a generic one. You can use this with React pretty well. And then we have Capybara, which is built on Ruby, and the tests are specified on Ruby as well. But it also uses the Selenium WebDriver. So let's keep going. So I called this runners because it's just the runner. It doesn't include the test case syntax. So the most typical is Karma, which was called Testacular. Not the best naming. That's why they changed it, probably. I also found Testem. I didn't know this one, but it seems to be around since a while. Then I found Wallaby, which is interestingly a commercial license, but it works pretty well with some IDEs, like JetBrains IDEs or Visual Basic. And then, of course, just for mentioning, Chutzpah is all the documentation is made in Windows console. So Windows environment, I guess, in case you're into that. All right, so much about vocabulary. Let's get into some frameworks. So I'm sorry, this part is a little bit repetitive. So I'm going to go through multiple unit testing frameworks. And I'm going to talk a little bit about how you can install them and set them up. And then some basic syntax examples. So bear with me with this. So Jasmine, one of the older ones, you basically install all of them the same way. You have to with Node Package Manager, you can install them globally. So you have the binary to your disposal, and in some cases, like Jasmine, it also gives you an init, which carries some basic scaffolding. Then the configuration on the right-hand side, you need a JSON, a configuration JSON file. You just basically specify the location of your test files, and also, if you would need them, some helpers which are executed before the test files. So the example would be, and this one, the left-hand side is going to be the same throughout all the examples. it's a basic player with one method. You pass it a song, and it just sets it playing to true and plays the song you passed. It can be a string or whatever. So in this case, we describe the test, which is called player. We do some basic initialization. We set up a before each, which is going to be executed before each test case. In this case, it's just one. We create the player, we create the song, we pass the song to the player, and we expect currently playing song to equal the song, obviously. And we expect the player is playing to be true, right? Pretty straightforward. Just pay attention to the syntax, because that's the main thing that's going to change, right? I tried to use expect syntax in all of them, so you can see differences, but it's not really that different, and it's not really that important either. All right, so let's keep on going with Matcha. So difference between Matcha and Jasmine is the first thing you see is Jasmine comes with built-in assertion library, right? And you can, I don't think you can change it, at least it's what I've seen. Matcha, it doesn't come with one, so you have to choose one. So the most basic stack would be Matcha and Chai, I would say, with Sinon as a mocking library. So the way you install this is pretty similar. You install with Node Package Manager, and of course you have to install also an assertion library locally to your project. And that's pretty much it. Configuration is just to show this, that you just create a test directory and you just create your test and you're done. There's no JSON. And again, the example is the same one. And a couple things change. Two small differences. There's a require all the way up, requiring chai expect. Obviously, you need a assertion library. And the other small difference is in this part, where before we said to equal as a lower camel case, now it's to dot equal. Not a big difference. Again, different assertion libraries. So we keep going. Jest. Jest is basically built on top of Jasmine, and it comes with some basic stuff within, built in, so less configuration, supposedly. You install it the same way. In this case, well, I could have installed it globally there. I didn't, but it's same thing, basically. You do have a package JSON because it's built on the Jasmine, same thing. Pretty much, you create your test directory, you edit your tests, and you execute. So the differences here are, you can see Jest don't mock. Per default, it mocks everything. So if you want something not mocked, you just specify don't mock. If you don't, basically you can check what has been called. It's basically like a spy on it. So in case you want to try stuff on your modules like this case, you have to specify not to mock it. But the rest is pretty much the same. On the bottom, again, to equal, this uses the same assertion library as Jasmine, so it's same syntax. Last but not least, a very newcomer to this, Ava. Ava has one particularity. It runs your tests not serially, but in parallel, which gives you a big performance boost. According to their documentation, they say about a 60% improvement against Matcha. So if if your tests are taking a long time and speed is important to you, this might be interesting. Also, doing things in parallel has some risks. To avoid these risks, you have to be really clean doing stuff. You have to avoid global states and other stuff. So also, I think it's a benefit. So I'm not going to go through this, but you get the idea. You install it, you configure it. In this case, the syntax changes a lot. So first of all, it supports natively ECMAScript 2015. And so you have it in front of you. Also the assertion library is power assert, which is interesting because it prints out a very informative output. So you can get a lot of information out of the output of this assertion library. So that's pretty much it with unit testing. Let's look a little bit into end-to-end tests. So the first one I want to look into is Nightwatch. So Nightwatch is interesting because it allows you to go against several browsers. It allows you to test against several browsers. We'll see that later. I tried to do this against Chrome and Firefox, but there's also a driver for Internet Explorer. I guess that only works in Microsoft environments, obviously. So the first thing you need to do is install Nightwatch, and as it works on top of Selenium server WebDriver, you need to install that. It's as easy as npm install Selenium standalone, and then you have to actually go there and download the jar file. It's a Java file. So once you've done that and you configure the thing, which is the documentation is pretty horrible. It's pretty horrible because it's one big chunk of stuff. But maybe your mileage may vary. So you configure it. You have to configure where you want it to launch the Selenium WebDriver, the server, and that's basically it. You're pretty well. You have to specify the test folder and a couple more things. There are many more optional configurations that you can read through in the documentation if you feel like it. So this would be a typical Nightwatch test. This is going against Google. So it's loading Google Norway. Don't ask me why Norway. And it's just checking that certain elements are present, certain CSS elements are present, classes are set, etc. And you can see this uses an expect style. It also has built-in an assertion style. And at the end, it exits. Client is here, the actual browser. And there's also, you can interact with the browser. You can start a global object which injects some variables into the browser. So you can do different things with this. OK, so then Casper.js. This goes only against Phantom.js. I've read there's ways to do this against Firefox too, or at least against a Gecko engine instead of a WebKit engine, because Phantom.js is WebKit. But I haven't seen this through, but you can check that out. But it's headless. It doesn't launch any browser windows, which Nightwatch did. So you install it, pretty straightforward. And you create your test. There's nothing else because Phantom.js is a dependency. It downloads that automatically. Nothing else to do. So what does this look like? Well, again, Google. It asserts that the title is this, that form exists, and it fills it with Casper.js. That's the first test case. The second one is it actually checks that this has worked, that this has actually changed the title of the page, and the URL has changed. There you go, and that it has at least 10 elements of in the results page. This runs. I tried this yesterday. Not going to do this now for time reasons, but it works. There's one interesting thing to note about this. As I was looking through this for the talk, there's a Chrome extension, which is called Resurrectio, which allows you to record actions while you're navigating. You can do clicks and interact with the website while you're recording it. So this then transforms into this kind of a Casper.js file, right? Pretty handy if you want to not write this by hand. All right, that was it. Now I'm not going to bore you anymore with this stuff. I'm going to go straight to React. So the way I did this part is I'm not actually gonna do a lot of slides. It's more about hands-on code, and also, so starting with unit testing, I'm using Matcha. I decided to use Matcha because it's something I like, and there's a lot of people that use it as well. Big community. So first off, testing your data flow. So I guess since this meetup is called React Madrid, I imagine you guys have a knowledge about React, right? So as you might know, React is a rendering engine. It's a library for rendering, usually against DOM. And it doesn't do anything with data or the data flow. It doesn't give you a clear instruction of how to set that up. So what Facebook did when it released React, also released Flux, right? Most of you know this. Flux gives you a pattern to handle your data flow throughout the application. It's pretty cool. It's a very good idea, but it's improvable, and a lot of people have improved it. And the one we like a lot at Sourced is Redux. So what Redux has done is it basically uses a very functional approach. It says, okay, so you have some actions, and you have a state. So if you apply these actions to this state, you will get a new state out. Right? And if you do this, a lot of times it's idempotent, so it would always do the same thing. It's very pure functional. So this is much easier to test because you can. This is actually called reducers. These functions that do this are called reducer functions. That's hence the name Redux. So this is very easy to test because the functions are pure, idempotent, very easy to test. So let's take a look at this. Give me a second, because I have to change the display mode. OK. All right. So if you were here on the first... So if you were here on the first talk of this meetup, and Miguel talked about Redux more in detail. And we talked. Well, he showed a project, sample, a proof of concept project, which is basically, which is basically. Oh, I didn't press keep settings. Sorry. And we want to do this. Sorry about this. And what did I do? Sorry about this. There we go. OK. Mirror displays. That's what I want. Apply. And keep this configuration. Why is this not working? OK. Oh, there we go. All right. Sorry about that. So I was saying, the project is actually, and I'm going to show you this, is a small Twitter-like project, which is called Twist. Twitter, twist. You don't tweet, you twist. So let's show that. It's localhost. That was Twister. And this is not launched, obviously. So let's launch this. Has ended. Awesome. OK. Whoa. I tried this before. I tested this before, and this was actually working. All right. Give me a second. Sorry about this. Oh, because it's npm start. Yep. npm start. There we go. What's up now? Yeah, great. Why did I do that? And up you go. All right. So just so you get an idea, it's a very basic. I'm gonna make this bigger. Just ignore the right-hand bar for now, or in general. It's a very basic form. It's a text area. You write some stuff. When you write some stuff, the number goes up. Eventually, if you reach 140, it will go red. It won't let you send the twist. And if you send the twist, it appears right there, right? The name is hard-coded. It was just a proof of concept. So you already know this, of course, if you were here last meetup. What we're going to do is, this had no tests. So we're going to write some tests for it, right? This is what good developers do. So first thing we do, as we already talked about this, we're going to do some tests for the flux part. So of course, what I did is I downloaded Chai to the project. I already have Mocha in my global configuration. I added Sinon, which is right here. And then, of course, I added the test command to, make it an alias and not have to write this entire chain every time. So I do npm test, and the tests run. OK, so this is the setup part, right? Let's take a look at the code. So if you remember, if you were here, you know that this has obviously actions, components, and reducers, because this is a Redux pattern. So the simplest part are the actions, right? The actions are actually, they're not really actions, they're action builders. No, what's it called? Action creators, sorry, I always forget. So the action creators give you back an action. So this part is the action. And this is the action type. The rest is up to you. You can write anything you want. So in this case, this is just reflecting when you change the form. So when you change the form, it's just a text area. We only want to track the text. So whenever the text changes, this action is dispatched. And it just gives you the type, which is input changed, and the actual text that was changed. OK, so it should be pretty straightforward to test, right? Right, it is. It's really easy to test because you just have to test one stupid method, or function in this case. So let's go to unit tests, action. As you see, I've already done this. I didn't want to bore you with my bad typing, very sloppy typing. So form spec is the one that actually goes with that. So let's do one thing. Let's see if this works. All right. So as you can see, we describe the test, and the test case is the form action should create an action to change the input. So on the text hello world, the expected action is this action type and the text that we specified. So the only thing we do is we assert that deep equal, this could be, no, it has to be deep equal, that the input that comes back from this, the output that comes back from this is actually equal to the expected output. So if we test this, if I hit enter, you're going to see a lot of output because all the tests are already there. But we will see each one individually. So, so this is actually the form action. There's just one test case. Should create an action to change the input. And it's green, and it works, and everything is peachy. All right, let's see a little bit more complex example. Also action, but this one's a little bit more twisted. No, not really. There's the same thing, but there's 3 different ones. So as you can imagine, it's exactly the same thing with 3 different ones. And the only difference is the ID is a number and not a text in it anymore, although you have the text when you create a new twist. So let me just show this again. So you can do 3 actions, basically. On the twist, you can retwist, retweet, favorites, and create a new twist, right? So, and this is why some have an ID, some have a text, because if you retweet or favorite, you just need to specify the ID of the tweet you are retwisting or favoring. All right, so pretty straightforward, right? Let's go into something more interesting. Reducers. So the reducers, let's take a look at the form one first. So reducers take an initial state and an action. Right? Action we've already seen. An initial state is arbitrary. In this case, the initial state, the state in general is going to look something like this. So we have an object which contains a property, text, it's a string. So In this case, we only have one action. So what we do is we usually switch through all the cases of all the actions. In this case, we'll just have one. So what we do is when we get when we get the action, we want to update the state. What it does is it does an object assign and changes the state and returns that new state. So as I said before, old state plus action equals new state, right? Very pure function, very simple to read, very simple to understand. So let's take a look at how we test this. So form spec. Form spec, it does the first very simple test you should always do is that if you're calling it without a state and without an action, it's going to return the initial state. This is important, otherwise you will screw up the state of your application. And as you can see, assert deep equal, that the reducer with nothing returns the initial state. Same thing with an existing state. Same thing if you pass an action first. So you have no state at the beginning, you pass it an action, and you get the resulting state, right? Same thing if you already have a state. So we have this state, we pass it an action, and it updates with the new text. As you can see, this is working. I'm not going to do this every time because you already saw this is working. Okay? So this is actually the reducer, the twist reducer, the form reducer, sorry. Right? Same thing with the twist spec. Not going to go through this, but it's the same principle. Okay, let's go back to the presentation. Not this one. All right, so we saw the data flow in Redux. It's very simple. You can either test the actions or you can test the reducers. Nothing else you can really test. And it's pretty straightforward, and it's pretty simple, and it's pretty clean. Redux is pretty cool for this. All right, how about components? Because components are really the central part of your application. It's what people are going to see and interact with. So again, this is done in Matcha. Let's go back to our code. So we have 3 components. If you remember the app, we have the timeline, which if you send multiple twitters, will hold the form and the stream of twists. And this holds the form, as I already said, and it holds each single twist within that collection. Right, so it's a pretty simple tree, and there are 2 things to note here. Timeline is the parent of both, so it's a smart component. Redux differentiates between smart and dumb components. Smart components are the ones that are connected to your store. Right? Store is just where it aggregates reducers. Don't worry about the store. Store is really very, very dumb, very simple thing. So timeline connects to the store, and in that sense, it's a smart component. Form also connects to the store. In that sense, it's also a smart component. But twist receives all its information from timeline, and it's a dumb component. It does not connect to the store. So since it's the dumbest component, it's the easiest to check out. Let's start with this one. So let's open components, and let's open form spec. Sorry, twist spec. There we go. So again, I'm going to do the same thing. I'm going to open them side by side so you can see it. Is it this one? Yeah. Okay. So as you see, the first thing we do is we have a helper function called setup. This is basically, you could say it's almost up before each. But in this case, it's just a helper function. What it does is it sort of mocks the properties, the props, that are going to be injected into the component. In this case, we mock one single twist, and there are 2 methods, which are retwist and fav, which we're going to spy on. So they're not going to really be functional. They're just going to we're going to be able to see who has called them, how many times they have been called, with what parameters, all of that. So with all of that, we render the twist component, which you can see we have required up here, imported. And by the way, you can see there's nothing relating to Redux here. So it's totally Redux agnostic. OK, so once we have rendered this, we get the output of the rendering, which is going to be an object form of the component tree. And we're going to return that with the props and, in case you will want to, the renderer. The renderer I'm not using. We're just using the props and the output in this test case. So what we do is we check that the output type is diff. So this is actually the parent DOM node. And we check that the class name is twist. So this is loading correctly. We check the children, which are avatar, username, date, and text. And for each one of those, we check that they have been set correctly, and we also check that the contents have actually got the props name that they should. Right? We can do this just by looking into their content, doing children, right? Their text nodes. So that's pretty straightforward. Now the interesting part. So we have two functions, two methods, sorry, and we're gonna test them. So basically, these two are the fifth and the sixth children, the sixth child. So we're gonna call on-click on each of them, right? Manually, we just call the function, and then with Sinon we assert that it's actually inside is actually calling the underlying methods, and it's a simple assertion. Have they been called once? It doesn't work if they've been called twice or thrice, just once. And as you saw before, it is working. This is how you can do this. Same thing again with the favs, right? So pretty straightforward, pretty easy to test, pretty easy to read, pretty easy to maintain. So yeah, pretty cool. Now, what about, this was a dumb component, what about a smart component? So if you know Redux, the biggest difference is a dumb component like twist, which I have twice now, you export the component itself, right? So there's nothing strange with it. You can, whatever this module exports is the actual component. So on the other hand, a smart component exports a wrapped component, wrapped by Redux, by a Redux provider. So this you can actually not use as is. But there's a simple way around this. You just export the component itself as well. And on the test, you just import that one. So no big problem at all. Here again, let me open this one in parallel. Timeline. So timeline, same thing. This has actually a couple of dispatch calls. Props dispatch is, that's the thing that's actually one of the things that is injected into the component from this Redux wrapper. So the first part is the same. We want to mock the props. We want to mock dispatch. Oh, sorry, we want to spy on dispatch. And then we basically test that some things have been loaded correctly. And then we test. Oh, here I don't actually test the dispatch one. That's my bad. But I know for a fact that the form one does. So same thing. Form spec. So the form one here, same thing, same concept. Don't get confused by a different file. Same thing. So in this case, we have on submit and on change. One has two dispatch calls. One has one dispatch call. First part is the same. And second part, if we call the onChange the second one, calls one time, just once the dispatch method, called once. And the second one is called twice the dispatch one, and one time the prevent default, right? So we test this and we test this, right? Also, really, really straightforward, easy to read, easy to maintain. There's no reason why not to do this. And as you can see, everything's green, everything's passing. Really nice. If things take a little bit longer, it warns you. This is why you can see this highlighted. All right, let's do some end-to-end tests for finish. Okay, so end-to-end testing. This is wrong. This is Nightwatch. Sorry about the matcha. End-to-end testing, Nightwatch. I use Nightwatch because I wanted some browser windows opening up and not just testing against Phantom.js. But really, this is whatever suits you. If you prefer headless environment, then use Casper. All right. So again, the configuration in this case was pretty straightforward. Let's close this. Make this a little bit less crowded. So package JSON in this case, pretty much nothing, no dependency because Selenium standalone. Obviously, I explained that before. Pretty much it because the Nightwatch is global, and I added the alias in npm the task browser. So in order to run this, I will need to do npm run browser instead of just npm tests. And I'm testing for Firefox and Chrome, right? Obviously, this is all very nicely configured. Took my effort, but it's working. And let's check it out. It's going to be quick because it's just one single file. Let's open browser tests. Just one single file, 3 different tests. So we want to open our server, which has to be running first. It's already running. I showed you the application, so we know that. So we want, this is using expect syntax now. I mixed it up. I'm sorry about that. I mixed it up with some assert syntax. You can forgive me, I hope. So what we do is we expect some elements to be present on the first test. Right? In this case, the text area. The text area is a nested component. So if this is there, things are working, right? So this is our first test. Second one is, remember when I typed that the number started increasing of the number of characters. So in this case, my Taylor is rich. Dot contains 18 characters. So I want to assert that the character count element contains 18. And then last but not least, the most important one, I want to check that if we go to the text area and insert my Taylor is rich, and then click on the form button, wait a second just in case, and then we can expect that there will be a new timeline collection of twists, and also that the single twist of that timeline will contain my Taylor is rich. So if this is working, my application is working on an end-to-end basis. So in order to run this, you already saw npm. Let's open this big. Run browser. Now you're going to see some windows popping up. First test. This is Chrome and Firefox. Second test. And now it's actually going to submit one. My Taylor is rich. You can see it was submitted there, and it's submitted here. So Firefox, everything is passing. Chrome, everything is passing. All right, so that's pretty much it. I hope you got something out of this. I think we have plenty of time for questions. Well, we have time for questions. So thank you. Questions? Yeah, here. Is this working? I don't know if that one's. There we go.
Can you test drag and drop operation?
I don't know. Honestly, I don't know. It's all about checking if the library of Nightwatch allows you that. You'd have to look in the documentation. I would think so. I would definitely hope so, but I can't answer that. I don't know. If anyone else knows, please. Now's the time. Nope. Yeah, and I think also the drag and drop is pretty non-standard right now. Still, unfortunately, I think that's not very homogeneously implemented. Maybe that's a reason. I don't know. More questions? More questions? We have time. Don't be shy.
Is there a sample available to download?
Yes, not yet, but it will be. And it actually, Miguel's sample from last week, that's online, and I did a pull request with some changes, which I need to correct because I did the pull request too fast and I have to fix some stuff, but it will be, and I will post it on Meetup, as well as these slides, which, by the way, I forgot to mention. These slides are made by Spectacle. Spectacle is a library, I don't know if you know it. It's pretty cool. It works with Redux and React. Pretty interesting, and you basically code your presentation. It's pretty fun to play with if you have a chance. So yeah, sorry, back to the question. Yes, they're going to be on the Meetup as soon as I can.
Okay, thank you.
Sure. Yeah, microphone, there we go. Here. Sure.
I'm pretty, I'm a newbie in the testing part of the development. I would like to know if there is a way, a better way to know that the page is load than waiting X milliseconds.
That is a good question. So you're talking about the end-to-end tests, right?
I have rendered things, but it's not for testing. I have used Phantom, but not for testing.
Okay.
So
yeah,
but I would like to use it.
So on the end-to-end part, so I have to excuse myself here because we're not actually doing end-to-end in production. I prepared this as good as I could for the presentation, and this is what I found. I found that they actually do a pause, and if you look at it, there's actually a point where it does. Besides pausing. So it does a pause up here, which is horrible. But then it does to be present before 1,000 milliseconds, right? It's still sort of a pausing because it's like, okay, wait, and then find out if the element is there. And looking at the, at the API, it looks like there isn't because, but I don't know. Again, if anyone knows this, please, now's the moment. Now's the time. But this talk obviously is more of an introductory talk, and it would be nice if in the future someone can do a more advanced talk about this with, more in-depth examples built on top of this presentation. But sorry, I can't really answer that much better.
Okay, thank you.
More questions? Anything anyone wants to talk about that? If you have done this, if you use this in production, end-to-end tests, how you've solved this, we'd love to hear as well. Well, end-to-end, I think all the hands went down, but definitely unit testing. For instance, is anyone using Karma? No one's using Karma? Karma. Testacular. All right. Well, anyway, a lot of areas that can be, talked about in future talks. So, again, anyone is invited. We're just two right now, so we'd love the company. If no more questions, thank you very much. It was great having you. Oh, right now we're gonna go for the beers. So hang tight if you wanna have some beers.